After the close of World War II, 1939 to 1945, the British led the Allies in turbojet technology and were able to launch the first combat-capable, fighter-oriented types into the sky. The first notable offering became the Gloucester Meteor, which recorded its first flight in March of 1943 and entered service in July of 1944, though it was used primarily to counter the V-1 rocket threat over the British mainland. Nearly 4,000 of the type would be completed, and the design also sold off to British allies across the globe. Powering this classic airplane were two ex-Rolls-Royce Derwent 8 series turbojet engines offering 3,600 pounds of thrust each. It was this foundation that helped to keep the British at the forefront of post-war jet-powered fighters for years to come, and technology allowed for a myriad of aerodynamic designs to be considered, with British engineers not in short supply of them. Along the road to establishing one of the world's preeminent jet-powered air services, the British considered an ocean of proposals from the usual industry players of the period: Gloucester, Fairey, Saunders-Roe, SARO, and Westland being just some of the names throwing their hats into the ring. For Saunders-Roe, primarily known for its oversized flying boat designs used throughout World War II, there emerged one of many unique offerings proposed to officials in the form of the Navy-minded P.148. The P.148 was a project aircraft drawn up by company engineers to satisfy a new Royal Navy specification, N.114T, of January 1951, covering a 14-ton, twin-seat, radar-equipped day-night fighter platform. Authorities sought a jet-powered type capable of reaching beyond 620 miles per hour, flying to an altitude of at least 40,000 feet and having a climb rate equal or greater to 10,000 feet per minute. Proposed armament was strictly air-to-air in nature, 4x30mm Aden autocannons as fixed, forward-firing weapons and, rather optionally, support for 4x air-to-air missiles, AMS. SARO's entry into the crowded field incorporated a conventional, slender fuselage containing the cockpit, avionics, fuel stores. These also carried in the wings, and the usual support systems. Of note was the two-seat, side-by-side placement, which only had the pilot under the bubble-style canopy with the secondary crewman seated lower in the arrangement, as in the eventual de Havilland Sea Vixen carrier-based fighters still to come. The pilot's canopy was offset to port side as a result, and the entire cockpit sat aft of a rounded nose air cone assembly which was intended to house an airborne intersection, AI, radar fit. The twin-spar wing mainplanes, offering notable sweep back, would be shoulder-mounted along the fuselage sides and set just ahead of midships. The fuselage was to then taper elegantly afterwards until terminated by a small rounded cap. Over the tail section was a single, rather squat vertical tail fin topped by swept-back horizontal planes, eventually arranged in the typical T-style or multi-up tail. For ground running, a conventional, retractable, or legs retracting into the fuselage, tricycle configuration would be used, though the legs were relatively short, giving the vehicle a squat appearance when on the ground. Dimensions included an overall length of 50 feet and a wingspan of 38.6 feet. Beyond the cockpit's appearance and interesting crew placement, one of the other unique physical aspects of this machine was its proposed turbojet placement, over the aft dorsal section of the fuselage spine, in essence also forming the base of the single vertical tail fin. The single-engine installation was to be aspirated by an intake found over midships and exhausted through a circular port under the rudder fin, with a relatively uncomplicated duct system in between to ease construction, maintenance, and general airflow. The engine of choice became the Rolls-Royce Avon Ra.10 series afterburning turbojet engine, 9,150 to 11,400 pounds thrust output. Though technological advances ultimately made by the Rolls-Royce company eventually led to the Ra.12 afterburning turbojet, 12,550 pounds thrust output, becoming the focal power plant. Engineers also included support for rocket-assisted takeoff, RATO, equipment to get the machine into the air as quickly as possible. Acceleration in early turbojets proved limited, so rocket power was used to offset this. As for the 4x30mm Aden autocannons, these would be seated ventrally in the fuselage under the cockpit floor, 2 cannons to a fuselage side, and a gun training radar unit would have been installed in the right wing member to aid accuracy. To this was added twin housings for up to 36 total, 2x18, aerial rockets at the fuselage sides in positions located aft of the main landing gear doors. Of course, provision was also drawn up for the carrying of the required air-to-air missiles, up to 4, mentioned in the original requirement. On paper, the P.148 would have been an excellent combination of performance, range, and firepower. As penciled out, the fighter was to have had a maximum speed reaching nearly 700 miles per hour with a ceiling near 50,000 feet, requiring cockpit pressurization as well as ejection seats, and a rate of climb of 12,320 feet per minute. In any event, the P.148 project went nowhere, and the eventual product to fulfill the Royal Navy fleet defense role became the classic Sea Vixen twin-boom fighter from de Havilland. This aircraft first flew in September of 1951 and finally entered service in July of 1959 with a modest total of 145 units completed for the Royal Navy. These flew into 1972.